Carbon monoxide, first preparation is direct oxidation of carbon in limited supply of oxygen or air gives carbon monoxide. Okay. Direct oxidation of carbon. Okay. Direct oxidation of carbon in limited supply of oxygen or air. Gives carbon monoxide, and reaction will be as follows: 2 carbon, 2C plus O2. O2 gas gives carbon monoxide. Gives carbon monoxide. Okay. Next, second method of preparation. In this method, it is produced in a small scale and pure carbon monoxide can be obtained. Dehydration of formic acid with concentrated H2SO4. Dehydration of formic acid. Dehydration of formic acid with concentrated H2SO4 at 373 Kelvin. Okay, the reaction causes and we can obtain carbon monoxide. Okay, 373 Kelvin, presence of concentrated H2SO4. Okay, reaction takes place and form carbon monoxide and H2O. Okay. Next, commercial method. Commercial scale, it is prepared by the passage of steam over hot coke. Okay. Passage of steam over hot coke. Okay. By this process, a mixture of carbon monoxide and hydrogen is obtained, which is known as water gas or synthesis gas. Okay. Carbon, by the passage of steam, what happens? 473 to 1273 Kelvin. Reaction takes place and we can obtain carbon monoxide gas and H2 gas. This mixture is known as water gas or synthesis gas. Okay. Next, instead of steam, if we are using air, another compound, another mixture is obtained. That is, instead of steam, we are using air. Okay. Produces a mixture of carbon monoxide and nitrogen, and this mixture is known as producer gas. Okay, and the reaction will be like this: carbon with oxygen and nitrogen. Okay, produces carbon monoxide and nitrogen gas. This mixture is known as producer gas. Okay. Next, these producer gas and water gas are used as important industrial fuels. Okay. Producer gas and water gas, they are used as industrial fuels, because when these producer gas and water gas are again combustion, carbon dioxide present in it gets converted into carbon dioxide and large amount of heat is liberated. Okay. On combustion, carbon monoxide in water gas and producer gas gets converted into carbon dioxide and heat is liberated. Okay, heat is liberated. So this can be used as industrial fuels. Okay, properties: they are colorless, odorless, water insoluble gas. Colorless, odorless, water insoluble gas. Next, they are used as powerful reducing agents. Powerful reducing agents, used as powerful reducing agents, and they reduces all metal oxide except reduces all metal oxides except alkali and alkaline earth metals, alkali and alkaline earth metals, then aluminium and few transition metals. Okay, and few transition metals. Okay, in the case of all other metal oxides, they are used as powerful reducing agents. Okay. Next, carbon monoxide is used in the extraction of metals from their oxide ores. So due to this property, carbon monoxide is used for the extraction of metals from their metal ores, from their metal oxide ores. Okay. For example, Fe2O3. Fe2O3 with carbon monoxide. Here carbon monoxide acts as a reducing agent and forms 2Fe plus 3CO2. So, metal can be extracted from its metal oxide ores. Okay. Next important property, carbon monoxide, the structure will be like this. Okay. So, this carbon contains lone pair and oxygen contains lone pair. Okay. And forms one sigma bond between C and O and 2 pi bonds are there. Okay. Due to this lone pair of electrons, carbon monoxide acts as a donor. Carbon molecule, see, carbon monoxide molecule is an electron donor. Okay, due to the presence of this lone pair of electrons. Okay, and so it reacts with certain metals when heated and form metal carbonyls. Okay, so with metals forms metal carbonyls. For example, in the case of transition metals like nickel, iron, etc., it forms metal carbonyls. That is, nickel with carbon monoxide gets converted into nickel carbonyl. So, metal carbonyls can be obtained. Due to the presence of this lone pair of electron, carbon monoxide acts as an electron donor. Okay. So, it forms metal carbonyls. This is another property. Carbon monoxide is highly poisonous in nature. Highly poisonous in nature. This is due to the following reason. That is, carbon monoxide forms a complex with hemoglobin in the blood. Carbon monoxide forms a complex with hemoglobin in the blood. Okay. Hemoglobin in the blood. This carboxyhemoglobin complex is 300 times stable than oxygen hemoglobin complex in the blood. Okay. Carboxyhemoglobin complex produced is 300 times stable than oxygen hemoglobin complex present in the blood. So what happens? This carboxyhemoglobin complex prevents hemoglobin in RBC from carrying oxygen around the body. Okay, this causes death. So it is highly poisonous. Okay, so this prevents hemoglobin in RBC from carrying oxygen around the body. Okay. So the hemoglobin is unable to carry oxygen around the blood. So what happens? It causes death. Okay, and causes death. So we can say carbon monoxide is highly poisonous in nature.